Means if a system is said to be linear, if it satisfies two conditions, the first condition is a system is said to be homogeneous if it satisfies this condition. If xt is the input to the system and yt is the output, and if we are scaling the input by a constant factor a xt, then the output should also be a scaled version. If we are scaling by a factor a, the output should also be a scaled version of that output signal. Then we can say that the system is a homogeneous system, and this a is a complex constant, complex valued, and this condition must be satisfied for all a. If this condition is violated at least for some value of a, then the system is not homogeneous. Okay, that is the homogeneity property. And the second condition for linearity is the additivity property. Additivity property means if we are giving, let's say, x1t is the input to a system, and let's say y1t is the output, and if you are giving an input x2t, different input x2t, then let's say y2t is the output, then the additivity property says that if we are giving sum of these two signals as the input, then the output should be okay. This is the additivity property. If a system satisfies this condition, then we can say that the system is additive. Okay, and these two properties together, homogeneity property and the additivity property, they are known as the superposition property. Okay, so now let us consider some examples of this linear system. Okay, before considering that examples, we can generalize this. A system is said to if x1 x1t x2t, if they are the input to the a system, and the corresponding outputs are y1t y2t, the corresponding outputs are y1t y2t y3t, then we can say that if we consider a linear combination of this input signals x1t x2t x3t, let's say the linear combination, we can write it as this is the form we'll be using xit summation. It is a linear combination of, actually it is a sum of weighted that input signals sit. It is summation over I, and then if the system is linear, the corresponding output will be, if this condition is satisfied, then we can say that the system is a linear system. Okay, so let us consider a few examples. If we consider a system, let's say xt is the input to the system and the output is t square xt. Is it a linear system? For checking the linearity, we have to verify both additivity and homogeneity properties. Is it a homogeneous system? If we are, what is that? What does that system do? Whatever input you are giving, it is multiplied by t square, isn't it? Is it? Input signal multiplied by t square, that is the output signal. Now, if you are giving a scaled version of the input, what will be the output? If you are giving it is at square xt. So it is it a is it a homogeneous system? It is a scaled version of this system, isn't it? It is homogeneous system. Is it an additive system? If x1t input we are giving, output is x2, let's say y1t, and x2t. So what is y1t? It is t square x1t. And if we are giving x2t as the input, t square x2t. And if you are giving sum of these two as the input signal, x1t plus x2t, what will be the output? If you are giving sum of these two signals as the input, the system is such that whatever input you are giving, that is multiplied by t square. Now if you are giving this as the input, what will be the output? T square into x1t plus x2t, isn't it? Is it that?
Yes, sir.
Okay. So is it a homogeneous system? We have already shown that it is a homogeneous system. So this says that the system is also additive. So it is a linear system. Is it? Since
Yes,
it
sir.
satisfies both the properties, it is a linear system. Now let us consider this example, xt to mod xt. Is it a linear system? Is it homogeneous?
Yes, sir.
Yes. How to prove that? Is it more homogeneous? So let me give you an example. If you are giving, let's say, this is, by the way, what is this system doing? Is it a full wave rectifier?
Yes, sir.
So what is the output corresponding to this signal?
So the negative parts will be flipped.
So is it this? This is this one, right? Is it that? Now if I am giving this as the input, what will be the output?
Same.
It is the
Same.
same, isn't it? Because this is this multiplied by -1. So does this satisfy the homogeneity property? What is that property? This signal, it is giving an output. If you are multiplying this signal with -1, we are getting this signal, isn't it? So if the output is also multiplied by -1, then we can say that the system is homogeneous. Is it a homogeneous system?
No, sir.
No, and we can verify it mathematically also. If xt, this is the system, sorry, mod xt. Okay. Now, if a times xt is the input, what will be the output? Is it this?
Yes, sir.
This is not same as a, isn't it? For some values, it is same. If a is a positive valued constant, this is same. Otherwise, it is not the same. Is it? So the system is not what? It is not a homogeneous system. Is it an additive system? Is it an additive
Sir,
system? Yes.
Sir, what if the A is complex number? Means what is the meaning of mod there? Then
Mod. Okay. In this case, it is the you can, for example, let's say
magnitude.
magnitude of the complex number. Okay.
Okay, sir.
So is it an additive system?
No, sir.
No, sir.
Why not?
Sir, because if we have two signals x1t and x2t, the respective outputs will be mod x1t and
So
mod
basically,
x2t
the output will be this. This is not equal to mod x1t
mod x1t
plus mod x2t. So it is not. It is not a not an additive system. And you can see it from here also. What is the sum of these two signals?
0.
0. What is the output? If you are giving
0.
sum of these two as the input, what will be the output?
Positive.
But if you are giving a 0 signal as the input, output is also 0, isn't it? If you are giving sum of these two as the input signal, output is not the sum of these two. Okay, the output is not the sum of these two. So it is not not an additive system. So the system is not linear. What about this system effects? Let's consider an example of a discrete time system. Is it a homogeneous system? Is it first of all, is it an additive system or not?
Yes, sir.
Yes, sir.
It is additive. You can easily verify that. Is it homogeneous? Is it a homogeneous system? Yes.
No, sir.
Huh?
Can we put complex number?
That is the definition of
then-
complex. I have mentioned that if you multiply with a complex valued constant, then the output should also be a scaled version multiplied by the same complex valued constant. So if you simply multiply with j, is it same as j times this?
No, sir.
No. So this is not it is an additive system, but not a homogeneous system. Okay. Just one more example. Xt to, let's say, 3xt plus 5. Is it a linear system? Is it a linear system? Is it
No, sir.
linear? No.
No.
Is it additive?
No, sir.
No. Is it homogeneous?
No, sir.
No. Okay, so this one, even though it is a linear equation, it is not a linear system. So now let us discuss the next property, that is the stability of a system. There are different definitions of stability. In this course, we will be discussing one type of stability that is called, it is bounded, okay, it is called bounded input, bounded output stability. Bounded input means we are giving an input signal xt. A signal is said to be bounded if its its maximum value is finite. It is a finite valued signal. Okay, so here we can say that this is the upper bound mx. Let's say mx, the upper bound is less than this mx. So we can say that the signal is bounded. And if we are giving a bounded signal as the input to the system, the output should also be bounded. If we are giving a bounded signal as the input to the system, the output should also be bounded. Then we can say that the system is bounded input, bounded output stable. Okay, it is a stable. Simply we say that it is a stable system. If you give a bounded input, output should also be bounded. Now, what about this system xt to 2xt? Is it a stable system?
Stable.
It is a stable system. If you are giving a bounded input, the output is always bounded. It is multiplied by 2 only, multiplication by a factor of 2. So it is a bounded system. Bounded output is always bounded if the input is bounded. Can you give an example of a unstable system? Example of an unstable system? What about an integrator? Is it a stable system or unstable system? Is it stable or unstable? Suppose I am giving a unit step as the input. Is it a bounded signal? I am giving unit step as the input to the system. Unit step is it a bounded signal? Amplitude is bounded, isn't it? Maximum value is 1. What will be the output? Output of that integrator?
Delta function.
What? Delta function. Integrator. You are integrating a unit step function. What is it? Delta function? If you differentiate
linear.
Ramp function.
Straight line.
it is a ramp function, isn't it? Is it a bounded signal? Is it bounded?
No, sir.
It is not bounded because as t tends to infinity, its amplitude tends to infinity, isn't it? So it is not a bounded signal. So this is not a stable system. Okay. Okay. Any question regarding this stability of a system? And if this condition is violated for at least one signal, then the system is unstable. This condition should be satisfied for all the possible signals. That means if whenever you give a bounded input, the output should be always bounded. Then only we can say that the system is stable. If it is violated for at least one signal, then it is not a stable system. There is one more property, that is the invertibility property. Okay, so we have a system. We are giving xt as the input to the system and yt as the output. Let's say the system is denoted by S. That is the system. We can say that the system is invertible if there exists another system such that I'm denoting it by inverse system S inverse. We should get back the same signal. Then we can say that the system is invertible. Okay, if we can get back the original, the input signal from the output, that means we can invert that operation, then this we can say that the system is an invertible system. Okay. So let us consider some examples. Let's say xt to x2t. Is it an invertible system? Is it an invertible system?
Yes, sir.
Yes. This is compression by a factor of 2. What is the inverse of that operation? If you are, this is time compression. And if you are giving this output to a time expander, like if a system that expands the signal by a factor of 2, then we can get back the original signal, isn't it? Now, what is the input-output relation of that inverse system? What is the input-output relation of that inverse system?
So t changes to t by 2.
Is it this? Is it this?
Yes, sir.
Yes, sir.
That is inverse system. And don't get confused with these two xt. Whenever we talk about a system, we denote its input as xt. Okay. Now, if we pass a signal through this system and that output, if you are passing through the second system, you'll get back the original signal. So the system is invertible. Now, what about this? Let us consider the discrete time counterpart of this operation, that is xn to x2n. Is it an invertible system?
No, sir.
No. What is the reason?
Sir, information gets lost in this.
Some information is lost, isn't it? Because, okay, if we consider this signal, let's say 0, 1, 2, let's say this is the signal, input signal. What will be the output? What is this operation? Downsampling by a factor of 2. We keep only the which samples?
Even, sir.
Even samples and discarding the odd numbered samples. So the output will be this. Let's say if this is 1 and 2, this is 1, 0, 1. Okay. So we are losing the information about the odd signals, odd samples of that input signal. Once the information is lost, we cannot recover it. So it is not an invertible system. So can we say that a system is invertible if and only if distinct inputs gives distinct outputs? Is it the condition? What is the condition for invertibility? For example, if you are giving, okay, this input, it is giving this output. Now, if you are considering a system, a signal, let's say this is 0, 3, this is 1, and this is 3. What about the output? What about the output? If you are giving this as the input here, even numbered samples are 1 only, same as this, but odd numbered samples are 3. So what will be the output? Will you get the same output? Is it the same output? Hello?
Yes, sir.
We are considering a system. What I'm saying is, if you are giving these two signals as the input to the system, we will get the same output corresponding to each of these signals. Okay, so more than one signal giving the same output, isn't it? Is it? So it is not invertible.